Hi class, we're looking at lesson 3.6. The objectives for this lesson are to define a variable in terms of another variable, as well as model distance, rate, time problems. Basically, these are the dreaded word problems I've been warning you about. They're not actually that bad unless you're on a train that's going to collide with one another, then you might be in a little bit of trouble. Couple of vocabulary terms here. We have consecutive integers. When we talk about consecutive integers, recognize that they're just integers that differ by one. Okay, so like 4 and 5, those are right after one another. And then we have an object in uniform motion. It just means that it's moving at a constant rate. So we're not worried about like starting and stopping and things like that. We just assume it's all an even pace, as you will. So let's look at our first example. The hardest part about these problems is writing the equation. If you follow the steps of defining your variable, okay, define your variable right away. What does it mean? Write it down. That's the first thing you should do. The second thing I want you to do is after you define your variable, start to draw a picture. I like pictures, okay? I'm not an artist, but I like pictures. Get something pencil to paper. All right, you can't do these by just thinking or making the problems appear. All right, so you need to make sure that you are working through making sure your equation makes sense, drawing a picture, convincing yourself that the equation is right. That's the important part here. All right, so let's try our first example. Here we have a consecutive integer problem. And it says the sum of 3 consecutive integers is 72. So notice here how I've defined x is the first integer. Well, if x is the first integer, what could we use to represent the second integer? Well, if they're consecutive, they differ by 1. So this integer is just going to be x plus 1. Well, what about the third integer? In relation to the first integer, remember it's plus 1 plus 2. So this is going to be x plus 2. And their total is 72. So if you see here, I let x plus 1 be the second term, x plus 2 to be the third. So now if I'm adding these three terms up, I get x, which is my first term, plus x plus 1 is my second term, plus x plus 2 is my third term. So one term, two terms, three terms. Add them all together and you get 72. Okay? So then we can solve by combining like terms. And we get 3x plus 3 equals 72. Subtract 3 from both sides, divide by 3, x equals 23. Are we finished? So we go back up to the problem, and the problem asks us to find the integers. So we're not done quite yet. We have to figure out, we've got the first integer, which is 23. So then we need to add 1 and get the second integer, and add another one and get the third integer. So you're not done until you've answered the question. You want to make sure you're showing all of your work for these problems. All right, let's try the next example. Again, you can pause this, try to do it on your own. All right, these are pretty challenging problems and they require thought. But you have to also recognize this is chapter 3 and we do build upon these, and these word problems are the foundation of the rest of the year. So you want to make sure you're getting them. All right, let's look at our next example. So we are now in an airplane, okay? And we have an airplane left the airport flying at 180 miles an hour. A jet flies at 330 miles per hour and it left an hour later. The jet follows the same route as the airplane on parallel altitudes, so we're not going to crash, okay? How many hours will it take for the jet to catch up to the airplane? So you got to think about these. Here's a table, and I like to use, especially with my rate, you have to recognize that rate times time equals distance. Rate times time equals distance. Speed times time equals distance, okay? And with any kind of speed problems, I like to put a table in which I have my rate, my time, and my distance. So this is very important, defining your variables. So our first variable here is I'm going to let t be the time of the airplane. Okay, here's the airplane. So if the airplane leaves, what's the time going to be for the jet? Well, if you think about it, if the airplane traveled for 5 hours, the jet would how long would the jet travel? Well, 4 hours. Okay, well, if the jet traveled or the airplane traveled 10 hours, that means the jet only traveled 9. How did you get that? You're subtracting 1. Okay, so we're going to subtract 1. That's that duh statement that a lot of times if I were to ask you those questions, if I would tell you the airplane traveled at 7 hours, you'd tell me, well, that means a jet traveled at 6. If the airplane, and I could keep asking you those questions over and over in your head, and you could answer them, but you have to come up with that expression, that T minus 1. That's the hard part. And it's obvious. I know it's obvious. And I always say, duh, Mrs. Mona, that's obvious. Yes, it's very obvious, but you need to put that pencil to paper, write it down. So I'm filling in my table here. You can see here's my rate of my airplane. Here's the time. It's T. Rate times time. Multiply them together. That's going to give us our distance. Okay? Now, our jet. Here's our jet's rate, 330. Here's our jet's time. Okay? The T minus 1. So if we multiply those two together, and I notice I use parentheses, we get 330 times the quantity, T minus 1. Now, they're traveling in the same distance because the jet is following the airplane's path. Okay, we want to know when they catch up to one another. So if you think about it, their distance, the actual physical distance that they're going to travel is going to be equal. It's going to be the same. They're leaving from the same spot. They're going to the same spot. So your distances are equal here. So if I set the distance of my airplane, which is this, equal to the distance of my jet, which is this, I now have a beautiful equation, looking down through here, that I can then distribute, combine like terms, and solve for t. My time is 2.2 hours, which is 2 hours, and 2/10 of an hour is going to be 12 minutes. Okay? Now that is the time for what? Well, you got to look back and see what I defined it as. T is the time the airplane takes. Notice how I use that here. So if the airplane traveled for 2 hours and 12 minutes, how long did the jet? How long will it take the jet to catch the airplane? Well, the jet only has to travel an hour less than that, so it will take the jet an hour and 2/10 or 1.2 hours or 1 hour and 12 minutes in order to catch up. Okay? All right. Might need to take a break. Go ahead and pause this. Try the next quick check. When you get a second, you can check your work and move on. All right, so we've got a 3 consecutive integer problem here. Here's my equation. First integer, second integer, third integer, okay? And my answer is 15, 16, and 17. Next question. Now I've got an airplane. One is leaving Dallas, and it's 2 jets leave Dallas at the same time and fly in opposite directions. So if you need to draw a picture, think about it. Here's Dallas, okay? Here's Dallas. And one's going this way, all right? And one's going this way. So this is my eastbound. Excuse me. Here's my westbound. So I'm told my eastbound jet is flying at a rate, and my westbound jet is actually flying faster, 50 miles per hour faster. I apologize. After 2 hours, which is their time. All right, so we have our eastbound. I'm going to let x be the speed of my eastbound jet. My westbound jet, think about it, if it's traveling 50 miles per hour faster, it's going to be x plus 50. That's my rate. My time for both of these is 2. So my distance traveled, again, rate times time equals distance. So if the total miles is 2,500, then Their sum of those distances is going to be 2,500 miles. So here's my eastbound distance. Here's my westbound distance. Here's my total distance, and I'm adding them together. Distribute, combine my terms, and solve. And I get 600 what? What am I looking for? X represents the speed. So that means my eastbound jet is traveling at 600 miles per hour. So how fast is my westbound jet? 650. Not too bad, huh? All right, go ahead and try the quick check. I believe that's it. Oh. Go ahead and try the quick check, and when you're done, check your answers. Here is our quick check for campers, and their distances are equal. So we have a speed times a time, and again their distances are equal. So the one is going to be traveling at 3 hours and 40 minutes, whereas the motorboat is only traveling for an hour and 40 minutes. Okay, so that's it. We then have Sarah and John. They're leaving Perryville. Again, these are traveling in opposite directions, so their total distance is going to be the 176. So if I let 2 hours is my time, my rate is X for Sarah. John travels for 2 hours, okay, and he is 12. John is 12 miles per hour faster, so X plus 12. Add them together, we get the 176 for our distance. Distance 1 plus distance 2 equals the 176. Distribute, combine like terms. We solve for X, which is 38. If we then find the faster speed is 50, because we need to add 12. Then you've got some great problems in the practice section of your packet, the extra practice you're welcome to do. We'll be working on these in class. Good luck. And honestly, there's no magic trick. You just got to work through them. Good luck.